Can you hear me? Hey, good afternoon, everyone. So I don't know if I can compare this with a Sholay movie or anything like that. It's going to be a little more serious than that. I don't know how many of you have heard of Apple-IBM partnership? Good. So as part of the partnership, first thing what we did is when we started setting up the delivery unit, we were on a mission to deliver 100 apps. These are apps which are not to be seen on the App Store. These are not the B2C apps. These are more of enterprise apps. These are apps that a pilot would use, that a ground staff in the airport would use, or a banker would use, and things like that. So obviously, it has. If I have to put characters from the Sholay, I'll run out of the characters if I put that on the architecture, right? So there are so many components talking to each other. So as of today, we started the partnership on 2014. In 2014, as of today, we have delivered more than 100 plus apps across 14 industries and 50 plus clients, and all of them are on Swift. So we started Swift much early, and as part of the partnership, we also are committed to Apple to evangelize Swift, to take Swift to the next level, and you will hear from Chris, to what level we are taking as part of this. So if you look at the enterprise space, right? Enterprise space building, how many of you have worked on Node.js? How many of you write server-side coding? How many of you have integrated your app to, let's say, a very serious backend like a legacy system, SAP system, or anything like that? Yeah, so trust me, that's where we are going towards. I think the B2C age is, more and more people are now moving towards using iPads and iPhones in the enterprise, because these are the same users who are pampered with having iPads and iPhones to book their tickets on Book My Show, right? So when they go home, when they go to office, they are given a very complex screens to work on, and that is changing. So we are changing the user experience of the employees, and that's where, if you look at it, I just wanted to show you. I will not walk you through this. We can have an offline discussion, but this is how your backend looks. The app is just one piece of the puzzle, but if you look at the backend, it is much more complex than that. How do you cache data? How do you integrate? How do you manage your documents, images that you're uploading on a secured platform? How do you do DevOps? The right version of app has to go with the right version of API, any database scripts that you have. So it's much more monstrous than what we would do in a B2C scenario. And for that, what we really need is this. So when we started Apple Garage, that's where we do most of the development. We have around 600 people there. Most of them are Swift and Node.js and Java developers. We wanted a rapid app development platform. We had a commitment that we will go live as early as 12 weeks on enterprise space, which is very serious, right? So the MVP should have been in 12 weeks. What we wanted is a full stack development, because I can't be handling multiple skills. If I know Swift, I want everybody, I should be able to do the front end, the back end, whatever else is required to build a complete end-to-end solution. And what I need is a scalable, performing mobile backend, which is very, very critical for enterprise and also the B2C apps. And fourth, most important is, I need it to seamlessly integrate with the cloud services. It could be the cloud services on the same cloud, IBM cloud, or should be Firebase on Google Cloud, or anything like that. So that's when we invested quite a bit. It started as a research project called Kitura. It started as a research project, and now, thanks to Chris and team, it's becoming the next best, I would say, mobile backend that you can really look at and rely on, right? So with that, I'll hand it over to Chris. I'm available for the talk. We are recruiting, so more than happy to have you on my team. Yeah.
Hello. Yep. So enterprise apps can be very complicated. But at the other end of the scale, you start off with relatively straightforward consumer apps. So if I'm building something that's maybe a game, that could be completely self-contained inside the device. I don't actually need an external connection to run a game. But I might get to the point that I wanted to store data off the device in order to, say, share high scores, so that every user of my game knows the highest score of anybody playing the game. I might also want to then be able to start sharing that information on Twitter or on Facebook, or start to find other players in my region and build teams. So you go very quickly from having a self-contained app to something that does actually want some kind of back end. And as you've just seen from AB, if you're building enterprise applications, which is more a projection of what my company already has, then you're certainly going to be using a whole load of back-end services like SAP and Salesforce and Oracle and Sage and IBM services. So the way this typically works today is I have my iOS engineer who loves Swift, wears the Swift t-shirt, and loves everything that they've got about iOS. But the back end is typically written in something else. Now, that could be Node.js, that could be Ruby, that could be Python, that could be Java. And whilst they're on the same team, they argue because everyone knows Swift is the best language and everything else is rubbish. Unfortunately, the Node guys know the same thing about Node, and the Java guys know the same thing about Java. So you've got this tension. And it's not just about whose is the best language. You also have interoperability problems. So it starts off with, on the device, I'm writing Swift code. So my data is declared as a strut or a class. So if I had some data for a profile, I might have a name, which is a string. I might have their photo for their avatar, and that might be stored as data. And I might say have their date of birth, which is a date. Now, if I'm going to store that on a server or fetch and populate one of these from the server, I typically have to use JSON, which is JavaScript object notation. So I have a JSON object, and I have those 3 fields in it. And on the server, I have Node.js. And Node.js has to parse that data and create its own implementation of the data. And that looks like it works pretty well. But if we look at just the photo in more detail, so on iOS, I'm taking a JPEG, and I'm storing it as maybe a UI image or maybe as data. Now, to get that to JSON, I go from data to string, because JSON doesn't have an implementation of data or UI image. In fact, it just stores strings, numbers, and Booleans. So I have no choice but to convert it to a base64 encoded string. Then it comes over to Node.js. Node.js has no sense of data either, so it has to store it as a string. So I've got an image that's actually a string. And if it needs to do anything with that, then you've got complex transformations that you have to do. And we've got the same kind of problem with date of birth and dates. So on iOS, I've got a date structure, and that knows how to do date formatting. When I move that to my JSON, JSON only knows about strings, and Node.js only knows about strings. Now, dates have a particular problem. Depending on which country you're in, is how they format them. Some groups do day, month, year. Some people do month, day, year. Some people do year, month, day. So the way that string is formatted is very dependent on a number of things. So what we generally end up having to do is break your date of birth down into 3 values, month, year, and day, so that we know which bit's which, and then have to do the same thing on the server. So I've gone from Swift types to something that's mostly stringly formatted. And you'll have seen a number of presentations for Swift that says doing things stringly is generally bad because it's not compile safe. So does that mean in order to use backends, I have to learn Node or Ruby or Python or Java or something like that? And as we heard this morning from John O, where he talked about one language everywhere, well, we now know the answer is no. I don't have to have a server that's Node.js. I can be doing that in Swift with Kitora or Vapor or Perfect. And the advantage of this is if I make my types conform to Codable, a new protocol that came out in Swift 4, then I can share exactly that same type on both sides. And that means that when I transmit data from the client to the server, there's no transformation. There's no chance that your conversions of dates or data will go wrong. Now, to use Codable, I set up an encoder. So I set up a JSON encoder, tell it to encode, and I give it an instance of my profile. And to decode it, I do the reverse. I set up a decoder, and I say decode to a type of profile with the data, and that's it. Now, it does happen to use JSON in between, but you don't need to know that. As far as you're concerned, it's a straight transform from the profile on the client to the profile on the server, and you are now sharing data types between the two. So what this means is when you went through Jono's talk this morning, and he talked about having Xcode projects, where you can have multiple components in that work together, then you can have one project that deploys to both client and server, and it's actually generating the way that it talks between the two, and you're sharing code on both sides. And that means your client and your server data types always stay in sync, and it's much safer. So that means that my front end and my back end developers hopefully stop arguing, and they are now happy. So this is great. So let's look at an example of fetching the profile for a given user from the back end to my iOS client. And we'll start with the client for that. So this is what you do with URL session. The first thing you do is you set up a bunch of URL components to set up your URL and your root context on that URL. So this is just a my host on /profile. Then the next thing you do is you want to fetch a particular user. So the user will have an ID, so I need to encode an ID. I then need to set up the URL request to be a GET, so I need to know it's a GET type request of that server. And then I set up my URL session and make the call, and that will get a callback, so a completion handler with a request data, a response, and a response error. So I have to have a web request, a web response, and an error from my call to URL session. And then inside that, I need to do a whole bunch of error checking. And then finally, I get to convert my response using the JSON decoder and Codable. So to make a web request, there's a whole load of web knowledge I need to have, even though I'm sharing types between client and server now. And we get a similar thing on the server. So even Swift servers, at the moment, this is what you have to do. You have to register a request on profile to do a get or a store. You get a request, you get a response. You then have to validate the parameters, so you have to look at the HTTP headers to check what the content type was to make sure that it's JSON, and then you get to convert the payload into your profile object. So does that mean in order to be a back-end Swift developer, I need to learn web programming? In fact, if I want to extend my app to have a back-end component, do I need to learn to do web programming with requests and responses and know about HTTP headers and HTTP status codes? Well, the answer was yes, but 3 weeks ago, we released this. We released CoutureKit, and we released Couture 2.0. So CoutureKit is a CocoaPod that you install into your iOS app that knows how to make requests of Couture. And Couture 2 introduced a new programming API that lets you build web routes and web requests which just look like Swift functions. There's no request, there's no response. It's just pass me a profile and I will store it. So in terms of CoutureKit, you go from this was all of the URL session code, to this. You set up your backend request, so create a new instance of CoutureKit for my URL. And then what I do is I say, I want to do a get. I'm going to give it a user ID for the profile that I want, and I expect to get a callback with a profile or an error if there was a problem. That's it. There's no web request, there's no web response, there's no web error, there's no checking HTTP headers for content type. I'm making what looks just like a Swift function call with a callback. And that's all you do to then make a request to get a profile from the server. So I'm using concrete types, they look like Swift types, it looks like Swift programming. And this is what now happens on the server once I've done my Swift type, which implements identifier, my Swift type that implements Codable, and my Swift type, which is a request error. So on the server, this is what we had before with web requests and web responses. And it becomes just this. I register that someone can call get on profile. That's the only web bit there. I then receive a user ID, which is an int. That's exactly the same thing that was sent from the client. And as Jono showed, we're sharing projects, so it's actually the same structure that's being sent. I'm defining the same structures on both halves of my project. And I'll respond with a profile or an error if I don't have that profile. And that's it. I write a Swift function that's going to get called by the client. So I'm writing Swift function calls on the client, Swift functions that respond to those calls on the server. And in fact, that means I can take my server code, I can put it into the client for testing. So again, it's the same Swift type, it's the same Swift type, and it's the same Swift type. So I just share those types between server and client. So that means not only are my front end and my back end developers happy with each other, ultimately, I don't need front and back end developers anymore. I just need Swift developers. And that doesn't mean we fire the back end team. Right? We don't get rid of the back end team. Right? We had useful people. Those back end team, we just make them into the same developers. So we now have a single team of developers. So the biggest question that's been actually asked several times today is, okay, so you can put Swift on the back end, and I can use it from iOS. And now we can see that it's easy to do. But can I actually use it for real apps? So the other thing that we announced 3 weeks ago was commercial support for Swift and Couture. So what this means is IBM will, for a fee, it's the only thing that we do in Swift that's actually charged for, is we will provide 24/7 support for anybody that wants to pick up the phone and say they have a problem. And this applies to Swift, Dispatch, Foundation, so all of the core components on Linux, as well as Couture and a whole load of modules that are part of the Couture ecosystem. And that's not just running on IBM Cloud. That's whether you're running on Amazon Web Services, Vapor Cloud, IBM Cloud, Azure, Google Cloud Platform, Heroku. Whether you're running it on a laptop that you have connected to the internet, we don't mind. It's supported wherever you run Swift. So in the same way that we're hoping you can now run Swift anywhere, we'll support you wherever you choose to run it. So with that, you should be able to become a Swift stack developer today, using both Swift on the front end and the back end and combining the two together. There's getting started guides on Couture.io. There's Build Hello World, which isn't particularly usable. It's that 15-minute demo. But after that, there's 2 tutorials. One of them takes the food tracker app, which Apple themselves use as the getting started guide to writing your first iOS app. We've extended that to writing your first back end for the food tracker app. And there's another one called To-Do List as well. We have our Slack channel if you hit any problems, you have any questions, or you just want to talk to people. And everything we have is on GitHub, open source, under an Apache 2 license. And then finally, as AB mentioned earlier, IBM is also hiring. We have a huge team here in Bangalore. We have another team, or 3 or 4 teams spread around other major cities in India. And if you would like to consider working for IBM, that's the URL to go to. Thank you.